Hi, I'm Phil, and today I'm going to talk about the Kitronik OLED screen for microbit. So I just recently received this, and these are my first impressions and a couple of the projects that I've been working on using it. Okay, I'm using a mind map, and I'm starting off at the top right. I'll describe the module, the hardware, the software, the projects, and some references. And I'll give you a demonstration of a couple of those projects. So what is it? Well, it's a small display with 128 by 64 pixels on an OLED screen. And it sits on top of microbit. Now, the really interesting thing is that the edge connector has been extended, so you can add additional modules that need that microbit edge connector. Okay, so the interface is an I2C interface, and all the software blocks are available to you from Microsoft. So you have Microsoft extensions that have been written by Kitronik, and there's also micro Python libraries available. And I've only tried the MakeCode extensions, and that's what I'll be using in my projects. So the projects, I've gone through some of the tutorials. I've commissioned it with very simple projects, which mainly are writing messages to the screen. And my latest projects are a full calculator, and I'll describe this later. So writing messages to the screen, so you can see on these photos, you can draw text and also rectangles, lines, and in this project, what I'm going to do is just write two messages when I press the buttons. That's the microbit buttons, A and B. And I'll also do a bit of exploration to see what the inversion is like when I press buttons A and B together. So for the hardware, I'm going to use microbit and also the Kitronik View Graphics OLED display. And here's my software. So it's quite simple. I turn on the graphics on startup, I clear the display, and I then align the screen for center. Then if I press button A, I simply write the message A on the screen, and it goes on line number 3, and I put a rectangle around it. And similarly with B, very similar, and with A and B, I just simply invert the screen. Quite a simple program, but it does demonstrate that the module does work. So here's something a little bit more ambitious. It's a simple calculator, and you can see the arrangement that I've got on the top. It's combining microbit with the Kitronik OLED screen. Then I've got a right angle connection, and then I use a keypad. So my objectives on this project are to do simple integer arithmetic with inputs X and Y, and using the operators, the result of X plus the operator, Y, and the result is Z. So I'm going to show the results of not only the answer, but also the steps involved on the Kitronik's View OLED screen. And part of this is to explore a combination of modules. So it's not only the OLED screen, I also want to explore the DFRobot math and control shield for microbit, which is my keypad. And I'm also using for Kitronik their AngleBit for microbit. So here are all the modules, and I'm going to assemble them all together in this project. And you can see the arrangement here. I've got right on top, I've got microbit, and it sits on top of the OLED display. Then there's the AngleBit, and that fits into the keypad. And here's my make code. So I've got a few extra debug statements right into the serial port, but generally it's a fairly small program, and you can easily extend it if you want to do floating point arithmetic. So on startup, I show the name of the program, turn on the display, and where it says set brightness, that's the set brightness of the neopixels on the keypad. So the idea here is you can give the user some feedback that they've pressed a key. And you need to set the brightness a lot less than the maximum brightness. And then I just simply form a title that goes on the first line of the OLED screen. And you need to configure all your messages, including numbers, as text. So that's why the text messages of make code are used here. And in the forever loop, I just follow the algorithm of adding X and Y and getting Z. So what's happening here is that I call two functions, call getX. There's actually three functions, call getX, then the operator, then I get Y. And once I press the button, enter the number, the equals, I show the result. So here are the functions for getting X. And you can see in the logic that I've got here, I'm only processing numbers between 0 and 10. And I'm doing the same with Y. And I give a little bit of feedback there. So if a key's selected, the neopixel LED on the keypad goes red for a very short period of time. And similarly with the maths operator, I select which maths function has been entered on the keypad. And here is the functions for processing. So this is an event. So if I press a number on the keypad, it then decides whether it's a number or an operator, and then proceeds. And if I press the DF, I simply reset the screen. So that should be an OLED, it's not a LCD. So I need to rename that function. And here are my references. So quite a good combination that allows STEM students to build their own calculator. This is my microbit calculator, and it's based on the microbit computer, and that sits on top of a Kitronik display, and the display also uses the 90-degree angle, so you can see them all aligned, and they're all sitting on top of a DFRobot keypad, which is called the math and control bit. So it's used for maths projects, but also for control projects. And to give you a bit of a demonstration, when I enter a number here, so if I enter the number 9, 9 will appear on microbit, but it also appears as X equals 9 on the Kitronik OLED display. What I want to do with that is to subtract 7, and what we have is y equals 7, and we get the answer. Just press, and here we have 9 minus 7 equals 2, and the answer appears there. And you can add larger numbers, but both x and y have to be integers.